of this unit. Radical equations and power functions. Okay, so we have a lot to kind of grasp today. Properties of rational exponents, radical notation, radical functions, radical equations, power functions, and that's kind of the gist of it. You'll see it in a second. So rational exponents. A rational exponent is an exponent that is a fraction, okay? Each piece of the fraction has a role to play. So if you look here, we have x to the p over r. P stands for the power, r stands for the radical, okay? So the numerator is the power, the denominator is the radical. And they're both real numbers, and r has to be a real number greater than 1. So if I have x to the p over r, there are 2 ways that I can write it. And these are your 2 ways. Questions so far? Let's go over your exponent rules. Do these look familiar from algebra? Good. So exponent rules, you have your product rule. The product rule is if you are multiplying 2 numbers with the same base, then you add the powers. If you're dividing 2 numbers with the same base, then you're subtracting the power. If you have a negative exponent, that means the number is actually written as a fraction. And if you have a negative exponent in the denominator, is vice versa, the number is actually a non-fraction. The power rule is if you're multiplying, if you're putting a power to a power, then you're multiplying the 2 powers. And expanded power rule, that means you're distributing the power to each factor. So you distribute the power to each factor. And it also applies for division. You distribute the power to every factor. And then the 0 exponent rule. Anything to the 0 power is 1. Do these look familiar? Sound familiar? Cool, cool, cool. All right, so here are examples that we're going to simplify. I thought I spaced them out more, but I didn't. I think I did. No, I didn't. I lied. Why didn't I? I don't know. We're just going to make it work. So 8 to the 2/3 means that a couple of things. I either can square 8 and then take the cube root, or I can take the cube root and then square that solution. I like to go smaller than larger. Some weird people like to go the other way. So me personally, I would take the cube root of 8 and then I square it. What is the cube root of 8? 2. And 2 squared equals 4. So the answer is 4. Yeah? What's a no? So we just said that the numerator and denominator represent the power and the radical, right? So the 3 represents the radical, which is the root. The 2 represents the power. So that's the operation that I'm following. So let's try it again. So we're going to simplify the numerator and denominator first. I have 16 to the 2/3, so I'm going to take the cube root of 16, and then I'm going to square it. And the cube root of 16 is? Oh, wait, I should have simplified even more than that. Reverse, reverse. Let's actually do the subtraction. Why am I going to subtract first? They have the same base. So I'm going to subtract the powers. What's 2/3 minus 1/6? Again, you can do, what'd you say? Yes. So if you're not as quick with that and you're like, I don't know. If you need to, you can always chopstick it out. It's going to give you numbers and you got to reduce them, but it never fails you. And so that gives me 9/18, which equals 1/2. So this means I'm looking at 16 to the 1/2. which just means I'm taking the square root of 16, which equals 4. Okay, on C, they have the same base. So since they have the same base, I'm going to do what with their powers? Add them. So I have 9 to the 1/3 plus negative 5/6. So now I have 1/3 minus 5/6. And I should get negative 1/2. Could you go through and do all that fun stuff again? Yes. Could you just go through and make this a 4 and make this a 6? Yes. And you're still going to get, is it 4 and 6? No, it's 2 and 6. I was like, that was wrong in my head. I did it in my head just fine. Two and 6. And 2 minus 5 is 3. And negative 3/6 is negative 1/2. So now we have 9 to the negative 1/2. Okay. So 1, I'm going to take the square root of 9. And 2, what does the negative tell me that result actually belongs where? If you have a negative power, it under 1. So it becomes 1 to the 3rd. All right, D is our power rule. So before I do anything, I'm going to multiply. So this is 25 times 1/3 times 3/2. And that's going to give me 25, 3/6. And that's 1/2. That's a little 5. Let me make that bad boy bigger. And the half power means you're taking the square root. And the square root of 25 is 5. Again, y'all, I do not know why I put all 5 of these on one page. Hindsight, 2020. All right, on the last one, we have negative 2/3. That means that this actually belongs in the denominator. So in the denominator, I have the cube root of negative 64 squared. The 2 is my power, the 3 is my root, right? The 2 is my power, the 3 is my root. The negative just tells me it belongs in the denominator. The negative from the power. The negative from the 64 is still there. So that gives me 1 over, what is the cube root of negative 64? Negative 4. So I have 1 over negative 4 squared, which equals 1 over 16. How did I put this all on one page? Who knows? Who knows what I was thinking? So this is applying all the rules. And hopefully you see how they're working. All right, so we're going to use positive exponents to write each expression. So we're going from a radical to a power, okay? So we want to go from radical to a power. Here I have the square root. So that means that my root is 1 and my root is 2 and my power is 1. So this would become 4x to the 1/2. Do we see that? Because it's x to your power over your root. Cool? Still with me? Okay, so let's keep going. This one. This time my root is 5. My power is negative 2. So this becomes y to the negative 2 over 5. But it wants it as positive exponents. So this becomes 1 over y to the 2/5. How do we feel about example C? So you establish what's the P, what's the R. So my P here is 4. My R is 3. So that means I have Z to the P over R, which is 4 over 3. Questions, comments, concerns? Now let's do D. D gets fun. All right, so D, we have a couple things happening here. It's both of these, so we work our way inside out. So I'm going to start on the inside. And on the inside underneath this cube root, we have y to the 1/2 times y to the 1/3. And that's because the root here is 2, the power is 1. The root here is 3, the power here is 1. So I can simplify the inside. And what do I get on the inside? What do you do with those two? You add them. So you have a 1/2 plus a 1/3, right? So you're doing a 1/2 plus a 1/3. There you go. So y to the 5/6. So you have the cube root of y to the 5/6. Do we see that? A 1/2 plus a 1/3. Okay. Then we're going to keep going. Now, our power is 5/6 and our root is 3. How do you clean that up? You have a fraction divided by a number. How do you clean that up? You multiply by the what? The what? The reciprocal. Wait, remember fractions? We don't divide them. We multiply by the reciprocal. So I actually am going to do 5 over 6 times 1 over 3. Because you multiply by the reciprocal. And the reciprocal of 3 is 1/3. And from here, I get 5 over 18. So the final answer is y to the 5 over the 18. Because again, we do not divide fractions. We multiply by the reciprocal. And reciprocal just means you are switching the place of your numerator and denominator. Questions, comments, concerns, hesitations? All right, so it's telling you what your x is, and I would like for you to evaluate it. So given this x, what do you get? Given and that gives us the square root of 4 to the 5th power. Well, what'd y'all get? So you get the square root of 1024. What's the square root of 1024? 32. Before you go. Questions, comments, concerns? Easy enough? Okay. Now, we're going to talk about graphing. Because I'm allowing you to use a calculator, I'm not about to go full depth into graphing. Does that make sense? You type it in the calculator and you look at the graph. Bam, that's how you graph. You'll just be able to analyze it. If it says, what's this value? Or what's this? What's the domain? What's the range? If I'm allowing you to use a calculator to graph, is there any reason why you should not be able to do that? No. Now, what will maybe be your hiccup is how to put it in the calculator as far as the cube root. So on the calculator, to get to the cube root, you press the math button, and you should see the little guy there. If you're on your 83, 84. Okay. The other way to graph this is to put it in parentheses, and you're going to carry it to the 1/3 power. So that's what I wanted to go with, the input, not the actual graphic. Okay. Questions, comments, concerns? So be mindful of how to graph. Make sure you know where the buttons are to get the roots and radicals that you need. For all other radicals besides square and cubic root, you're gonna have to write it as a fraction to take the root of it. So if it asks you to find y equals, pen doing crazy things. The fifth, you're gonna have to put it in as x caret 1/5. Because there isn't a square root of the fifth power button on there. Root of the fifth. You know what I'm saying. That button doesn't exist. Okay. Got it? Yes? Do we need to go over graphing any deeper? Cool. Didn't think so. All right. The other thing is that you will have graphing word problems on there. So apply your information. And so here it says approximate n to the nearest 100 whole number for islands of 500 square miles and 1,000 square miles. Interpret your answer. So it's telling you your A and you're plugging it in. Just make sure you're understanding evaluate. We just did straightforward evaluation with our 16 and our 64. Those were straightforward evaluations. This is a word problem based evaluation. So make sure you're reading and you understand what each variable represent. So here it's telling me the area. So this is an A value. Here's another A value. So it wants me to evaluate N of 500 and N of 1,000. And so I would take those values, plug them in, and evaluate. That's literally what it wants you to do. Does that make sense? So just make sure you're reading and plugging in for the right parts. Do y'all need me to go any further and actually evaluate it, or are you comfortable understanding? So in the calculator, you would type 28.6 times the cube root of 500. 28 6/10 times the cube root of 1,000. And then you get your answer, okay? Word problems aren't really difficult. It's just you have to take the time to figure out what is it asking of you, all right? And then it asks you, is it doubling? And the answer would be no. Once you see it and do it, it's not doubling. But that's just a straightforward word problem, okay? Okay, now we're gonna go into radical problem solving. So step one, you wanna isolate the radical on one side of the equation if necessary. Step two, raise each side of the equation to the same power to eliminate the radical. Step three, you wanna solve the resulting equation using techniques that you learned in previous chapters, so factoring, whatever needs to take place. And then step four is check your solutions, okay? This is extremely important because solutions do not work if they do not work in the original equation, they're called extraneous solutions, okay? And therefore, sometimes there's no real solution. If you don't do step four, then that's on you. But those are our 4 steps. So we isolate, we raise, we solve, we check. Isolate, raise, solve, check. Okay? So our first example here we have is 2x equals the square root of 21 minus 5x. So the first thing you want to make sure is that it is isolated. Is our radical by itself? The radical is by itself. There's nothing around it, right? Nothing on the left or the right. It's all up, okay? Second thing we're going to do is raise both sides to the power that you need. Well, if this is a square root, I'm going to have to raise both sides to the second power. That's because the opposite of taking the square root is to square it, right? So this leaves me with 4x squared equals 21 minus 5x. And then step 3 says to proceed solving it as if you have in previous chapters. So this is a quadratic, so I'm going to solve it as a quadratic. And I have 4x squared plus 5x minus 21 equals 0. So I'm going to ask myself what multiplies to give me negative 48, but adds to give me 5. What multiplies to give me negative 48, but adds to give me 5. Huh? Oh, it's not 48, 44. I can do that. I'm at 84. I'm saying wrong numbers. 84, y'all. We're there. 21 times 4 is 84. Huh? I'm so sorry. 21 times 4, right? Yeah. 7 and 12. And it would be a, yes, positive 12 and a negative 7. And then I proceed to factor. And that gives me 4x, x plus 3, take out negative 7. That leaves me with x plus 3. So those are my factors. And what do I do with each factor? I solve. I said each factor equal to 0. So there we go. Okay. So now I have them. And then the fourth step tells me to do what? I plug it in and I check and verify. And you're plugging it back into the original. So I'm plugging it back into the original. So I want to know, is negative 3 going to give me a true statement? So if I have 2 times negative 3 equals 21 minus 5 times negative 3, that gives me negative 6 equals 21 plus 15 is 36. And so the square root of 36, it is, but it will not be on the graph. It will not be. So this is a non-true statement. So this is an extraneous solution, not a real solution. Are we ready to do the other? Huh? It just, everything just keeps building onto each other. Yeah. So you look at the root. So if this is square root, then the power is going to be squared. If it had been cube root, then the power is going to be 3. All right, so I checked the last one. So we have 2 times 7/4 equals the square root of 21 minus 5 times 7/4. That gives me 14 divided by 4 is 7/2. This gives me 35 over 4 and 21 minus 35 over 4. 49 over 4? Yeah? Yeah. I believe it is too, but y'all know me. I think so. I think I may have done good here. And so the real answer is 7/4. So the negative 3 is my extraneous and the 7/4 is my real. That is why you have to check. Okay, so what this means is if you were to graph these two lines, so if you were to graph 2x and graph square root of 21 minus 5x, they would only intersect at 7/4. Does that make sense? That's their x value of intersection. All right, our next one. So if you look at this one, first step is to isolate the radical. What needs to move in order for this guy to be by itself? 4. So I'm going to have to subtract 4, right? So now we're working with the cube root of 3x minus 1 equals -2. Huh? Did I do something? Oh, I don't know why I did that. I don't. All right, so then the power that I'm going to use is the third power. So that sets this free. 3x minus 1 equals -8. And just like good old algebra, add the 1, gives me 3x equals, divide the 3. So then after I do that, I'm going to plug it in. So I plug it in. I will tell you more than likely when there's only one solution, it's usually just the real solution. I said yes. It's real. So we end up with 3, -7 minus 1 is -8 plus 4. And the cube root of -8 is -2. -2 plus 4 is 2. And therefore it is real. Yay. Huh? I just added and multiplied. You depended on the calculator far too long in your life. And I was kind of taught not to do that. All right, so here we go. So this one's a little fun. Notice here that I have 2 radicals, okay? You do not combine them. I'm 100% positive that you do not combine the 2 radicals. You want them on separate sides, however, but you do not combine the 2 radicals, okay? You usually move the smaller one. So we're going to subtract square root of 2x. So we're going to be working with the square root of 13 minus 2x equals 5 minus the square root of 2x. Okay? We're still going to square both sides. However, when we square the right side, we're going to have to use what? FOIL. Good old friend FOIL. So when we square that side, we have to use FOIL. And what's going to happen is FOIL is going to get rid of our square for us. We just have to do a little work to get there, okay? So I'm going to go ahead and write 13 minus 2x over here. It's going to be waiting for me to get my life together. So I have 5 minus the square root of 2x times 5 minus the square root of 2x. 5 times 5 is 25. 5 times the square root of negative square root of 2x. Then I'm going to end up with another -5. I forgot my 5 there. And then a negative times a negative is a positive. So I end up with positive 2x, not 4. Because a radical times itself just sets itself free. Oh, I don't know where that came from. I don't know. Let's just pretend that it was, but keep it going. All right, so then we're going to keep going. And so combining like terms with 25 minus 10 square root of 2x plus 2x. And now we can come over here and be equal. So 25 minus 10 square root of 2x plus 2x. What do you notice happens to my 2x's? It's written, I promise. Oh my gosh. Let's try that again. Oh, okay, Gina. Oh, it's the internet. It's not me. No. Yeah. It just kicked me out of everything. No. Oh, it is. It's like one little tiny one down there. I thought you were being funny. I was like, I don't. No, we weren't done. I had so many examples of everything that you would see on your thingy.
Wait, did the recording say?
The recording's still, well, I think, is it still going? I think it's just that computer lost internet. But it's still working because this computer still has internet. Yeah, this computer still has internet, but that one lost internet. Well, the problem is there's no internet.
Yeah, that was kind of error. You were hacked.
I know, we've been working just fine. Well, you all have to have John like Dario. Or let me just finish it and I'll post it for you. I don't know what happened. Hooper Scoopers. Yeah.
There's a point.
No. I'll just keep going. At home, people, can y'all hear me fine? Well, Zario said he can, so I'm assuming y'all can too. Is it fixed?
Yeah, you got full Wi-Fi.
Okay. Sorry for our faulty internet. I don't know what else happened, but okay, cool. So then now you're going to notice that I have a negative 2x and a positive 2x. I'm going to do what? I'm going to combine them. So minus 2x. Okay. Guys, these things be playing with my emotions. I think I'm good now. And then I'm going to subtract 25. And that's going to give me negative 12 minus 4x equals negative 10 square root of 2x. Is it? I did. You heard me say it. Okay. So then this is going to become, I'm going to multiply everything, but I don't want to deal with the negatives. So is it okay if I just multiply everything by a negative 1? Is that cool with y'all? Y'all see what I did? Anyone's like, Miss, where'd that come from? No? Okay, good. So then now we're going to have to keep squaring and keep going, and I'm tired. But we're going to square again and just keep going. You don't have one like this on your test, but you may have one on your homework. But it's not on the test because it is a long problem. So you would keep going, you square both sides. So you got to do FOIL again. And then now you end up with 144 plus 16x. Is it 16x? 96x. And then 16x squared, right? I was like, dude, you're throwing me off in my brain. But I was going in order, and I was like, what are you doing? And then 200x. And then now you would factor, and I'm going to stop right here. And so you go through factor or quadratic or cross or whatever your heart tells you to do to get to your final answer, because it would be 16x squared. What's 200? And minus 104x plus 144 equals 0. And then you would have to go through and factor all of that. And I'm gonna let you do that on your own lives, with your own lives. I did all the hard work. You should be able to factor. Huh? What? They all have 8. Because 144 isn't divisible by 16. You get what I'm saying? All right.